Hi guys, welcome back to my analytics channel. For this video, I will be sharing to you on how to use the RapidMiner. RapidMiner is an amazing tool. It provides you the statistics, the data description, the graphs, and process your data using various algorithms. Actually, I learned using this platform through the rapidminer.com YouTube video demonstration. It helps me on how you import your datasets from your Excel file, setting the label for prediction, applying your model, testing your model, and validating your model. Okay, this time I would like to show you how to do it. So let's start the demonstration. Okay, before you import your data into the RapidMiner platform, you have first your data sets, okay, saved in your Excel file. As you can see, I have here the data. So I have a total of 1,777 data sets. And these are the GPA grade of particular section. And this is the classification. Okay, I will be using this data to be loaded in the RapidMiner platform repository. For me, I save my data sets in my desktop. So all you have to do, this is the platform. This is the workspace of the RapidMiner. So all you have to do, just click this add data for you to load your data sets and browse your data sets. For me, I save it in my desktop. Okay, so I have the data sets here. Then you click the next button, and there you have it. This is your data, and just click the next button. So as you can see, the transformation of your data are treated as integer for this particular numerical data, and this part is your classification, and this is treated as polynomial. Since there's no problem because I already cleaned the data, but in RapidMiner, if you're using the RapidMiner, you don't need to clean your data. All you have to do is to use the filtering mechanism of RapidMiner and exclude those missing values. Then click next. Okay, then finish. Then, okay, we have already loaded our datasets file in this folder, okay, under the local repository. And let's check the history. And this is now the history or the example sets. We have 1,777 examples or datasets. Then you can check the statistics. Okay, automatically it will compute the total average of each GPA grade. And there's also the minimum and the maximum. So for this particular statistics, so as you can see, our list here are competent, and most of the students are in a capable categories. As you remember, so I have three category here: the competent, the capable, and the challenge. Okay, for this particular part, so most of the students are capable. Okay, and you can also check the chart here. So you can choose the chart that you want to apply. Okay, like this one. So these are the graph for the GPA Pro 2 and Pro 3, but you can select also the program. Okay, that one. Okay, except the classification. Okay, you can do this. Okay, then you have automatically the graph for you. So this is the good thing about this platform. Okay, it provides you the chart. Okay, and just choose the. Okay, next let's build our model. So all you have to do is to click this design button. Then we will drag our data sets, okay, from this area. Okay, this is the process area. Then we will call the operators set rule. Okay, the set rule operators, and drag it here because we will be going to set the predictor of our model. So we will change the or set the attribute name here, the parameters. Okay, but you need to connect first before setting the parameter to remove this icon. So it means to say that you have to do some connection and selection. So we choose classification as our target attribute. Then we make it as a label. Then since I'm going to know the simple distribution of my data set, so I am using an Naiva's algorithm. Okay, so actually this is a probability because I want to know the probability or the distribution of the GPA grade. Then you have to do some connection here to your training, and you connect your model to the result. Connect your model to the result. Since we have already built our model, let's try to run this model. Okay, so we have already now the result of the simple distribution using the NiFi's algorithm. So all you have to do is to click this one and you have your distribution model for the classification of the GPA grade. As you can see, we have here 62%, 18%, and almost 20%. So we have also the chart, okay, for the graphical presentation of the distribution. Then for this attribute, you can select which graph do you want to display. Okay, this because I have three data here, the GPA grade for Prog 3, Prog 2, and Prog 1. Okay, so this is the distribution. Then you can also have your distribution table here. So automatically it will compute the mean and the standard deviation of all the GPA. Okay, so this is a very good tool for those who would like to analyze or process their data using this RapidMiner platform. Okay, then we will apply our model. So let's go back to the design view. Okay, then we apply the model and let's check the performance of our model that we built. Okay, so you go to the operators. Okay, so this is the operators. You type a apply model. So all you have to do is, okay, this is the apply model. You have to drag this apply model here, and you have to connect your model. You connect your model to this particular, okay, just okay here, and is this one to the unlabeled. Then after that, you have to, okay, so we're going to check the performance of our model. Performance, okay, so we will use a simple performance here. Okay, just performance. This is the performance. Okay, then you have to connect the performance, okay, here, and your performance here in the result. Okay, so since we have already connected our model, so I think we have to delete this. No, we have already connect our model to the performance, okay, and connect it to the result. Then let's run this one. Okay, so now we have our result. This is the result. As you can see, okay, this is the confusion matrix. So we have accuracy of 94.54 for the good viewing. This is the confusion matrix. We have 94.54%, and true capable is 91.59%, 99. This is a good model. Okay, then this is a description. Okay, since we have already checked the performance of our model, now let's proceed to the validation and testing of our model. And to do this, we have to do some cross validation. So we need to delete this first, delete this first, and delete this first. Actually, you can save this using the store process. Then let's apply the cross validation of our model. So all you have to do is you go to the operators tab, then type a cross validation. Validation. Okay, then you drag this here. Then you do the connection. Okay, you extract your label here in the cross validation. Okay, but we cannot yet connect this cross validation here. So we have first to apply the our algorithm by double clicking this one. Then let's say we will apply a different algorithm, K and N. Okay, for this model, okay, then you have to connect the training. We have our training processor, and this is our testing. Then you connect the model. Okay, then to that, then you have to apply the model in our testing part. You have to call again the model here and apply that model, and you label the testing here. Then after that, of course, you have to call again your performance. Okay, so the performance that we used a while ago is the performance. Where is it? Performance here. Okay, then you apply. The next is you apply the model. Okay, let's check the performance of this model. Our performance to performance. Okay, then you go back to your process and connect this performance to the result. Okay, so okay, check it again. So we already done that, and now let's run this model. Okay, so we have now the result of our model, and this is now the result. We have 98.031.27 standard deviation. So as you can see, you have here your class precision and class recall. I think this is a good model, okay, to for this particular data set. But if you want to apply other algorithm, all you have to do is to change this algorithm that you set here. Okay, all you have to do is to delete that or type, for example, this is the algorithm that we use, okay, a while ago. So you can do the connection here, you connect the model here, okay, and run this one. Okay, so our result for that model is, okay, we have 94%. Okay, this is the performance of our model using the naive Bayes algorithm. But for KNN, so it shows a higher accuracy result, which is 98%. This is how you use the RapidMiner. It's important that you build your model, then you select an algorithm that appropriate to your study. So, but in my study, I will be using the KNN. Okay, this is a very powerful tool for you to process your data. I hope that you learned this simple demonstration, okay, for you to start using this platform. This is a very good platform. Okay, thank you for watching.